Hello students, welcome you all on your own learning platform Competitive Chemistry Circle. Today we are going to discuss an important topic of atomic structure. This topic is very important if you want to write the electronic configuration of any element in terms of sp,d and f orbitals. So before writing the electronic configuration, you must know what are the quantum numbers. Can anybody tell me what you mean by the word quantum number in the comment section? If you know the definition of the quantum number, please write below in the comment section. Quantum numbers is just like the address of electron. To locate the position of electron in an orbital. Orbital is a region where the probability of finding of electron is maximum. There is a probability, not confirmed location of electron, because the electron have a dual nature showing the particle as well as the wave nature. Okay, so in order to determine the position of a particular electron, we must know the certain set of numbers to locate a particular electron. Just like if you want to locate a particular person, then you must know about the country where this person is living. If you come to know the country, then you must know about the state, then city, then address. In that way you can identify or locate or meet that person. Similarly, if you want to meet the electron of a particular atom, you must know the quantum numbers. Quantum numbers, in one word I can say, these are the address of electron. These are the address of electron. Let's start without your wasting time. Before starting the quantum number, I want to explain from where, what is the origin of the quantum number. Actually, there is an equation, I think most of you know, Schrodinger wave equation. This wave equation result in development of the concept of the quantum number. Let's start. Keep watching and learning. See, we have a Schrodinger wave equation. This equation seems to be very complex to you. Don't worry, there is no need to memorize this equation. This equation indicates that the electron have a three-dimensional wave-like properties. Electron can move in the x-axis, y-axis, and the z-axis, or you can say the directions. Okay, d psi square, d square psi, dx square, d square psi, dy square, d square psi, dz square, and plus 8 pi square mh square e minus v psi is equal to 0. Second order differential equation. You will learn about this in differential equation in mathematics. So x, y, z are the coordinate axes of the electron waves. Clear? Where m is the mass of electron here, m is the mass of electron, E the total energy of that electron, V the potential energy, and one important term that is going to be repeat in all the terms is psi. Psi, my dear student, it represents the wave function of electron. Because the electron now have the wave-like characteristic, it represents the wave function of electron. Psi has no physical meaning. It can be positive as well as negative. But the most important thing, my dear student, is psi square. Is psi square. It represents the probability of finding of electron, because it can be positive or negative if I put the square of it, because any negative number always have a positive value if we make it square. So it represents the probability of finding of electron and it's always positive. We are not going into the detail of this Schrodinger wave equation. We are just simplifying the chemistry concept. When above Schrodinger equation is solved for the bound electron, it means whose electron is in position to be determined, the three constants are obtained, which gives the value of the first three quantum number, where n, l, ml, except ms, which is theoretically defined. My dear student, I am going to tell you very important concept. We have total of 4 quantum numbers, but only first 3 quantum numbers are determined with the help of the Schrodinger wave equation, and the last quantum number is theoretically defined. Let's learn. It starts with the topic of the quantum numbers. See, my dear student, quantum number, as I already told you, these are the address of electron. To determine the position of electron, we have four set of quantum number, where n is the principal quantum number, or you can say the principal quantum number is indicated by the symbol n, where L is the azimuthal quantum number or subsidiary quantum number, and Ml is the magnetic quantum number, and the last is Ms spin quantum number. See, we cannot determine the azimuthal quantum number directly without knowing the value of principal quantum number. Similarly, we could not determine the magnetic quantum number without knowing the value of azimuthal quantum number and the principal quantum number. So I put the arrow. These quantum number must be determined consecutively. Okay. So if you know the value of principal quantum number, then only you can determine the azimuthal quantum number. If you know the value of azimuthal quantum number, then only you can determine the value of the magnetic quantum number. These three quantum number, as you are seeing in this arrow, we can say these are derived from the Schrodinger wave equation. It means mathematically proven quantum numbers are first three quantum numbers. But the last quantum number is theoretically defined. It is spin quantum number. Let's first discuss about the first three quantum number that is derived from Schrodinger wave equation. N. Principal quantum number, its value is started from 1, 2, 3 and up to infinite. The maximum value of the principal quantum number can be infinite and is starting from 1, not 0. Remember, not 0. Principal quantum number represents shell, orbit, energy and the radius. It represents shell or the orbit or the energy level and the radius. But my dear students, some of the students may be confused, sir, if the orbit is not existing, shell is not existing, these are the this particle nature concept. So why we are using? These are just the analogy so that we can understand the quantum number better. Just we are relating. In real, orbit or the shell is not existing. We replace the orbit with the term of the orbitals. Then azimuthal quantum number, its value or formula, general formula, is from 0 to n minus 1. 0 to n minus 1. It means all the values from 0 to n minus 1. For example, if you have n is equal to 2, I put 2 here, then answer will be 0 to 2 minus 1, that is 0 to 1. 0 and 1 will be the values. Azimuthal quantum number represents subshell and the number of subshell. Subshell, they indicate the subshell. It means type of the subshell, S subshell, P subshell, D subshell and F subshell. And also the number of subshell, how many P subshells are there, how many D subshells are there, like that. Okay. And magnetic quantum number, its value, see, if you know the value of L, then only you can approach to the magnetic quantum number, because the magnetic quantum number general formula uses the value of azimuthal quantum number. Magnetic quantum number can be determined with the help of minus L to plus L formula. It means all the values that ranges between minus L to plus L. It represents the number of orbital, orientation of the orbital. It represents number of orbital and orientation of orbital. Okay. Then after we have spin quantum number. It has only two values. If suppose you assume your electron as a football, you can spin the football either only in the two direction, clockwise direction or anti-clockwise direction. If the electron is revolving in a clockwise direction, and there is a 50% chance that the electron revolve in clockwise direction and 50% chance that the electron revolve in anti-clockwise direction. So the probability is 50-50%, or you can represent as half. So this spin quantum number plus half for clockwise rotation of electron and minus half for anti-clockwise rotation of electron, and is also like up spin and down spin. If the electron is revolving in a clockwise direction, you represent the electron like this. It means up spin of the electron, clockwise rotation. If the electron is revolving in anti-clockwise direction, you represent it as down spin or anti-clockwise rotation. It represents the spin of electron. Now my dear student, we are going to discuss an important concept, that where actually the electron is present. In an atom there is a shell, not actually present, shell or the orbit. Inside the shell it is assumed that there is a subshell. Inside the subshell there is an orbital. Inside the orbital electrons spin. Electrons are present which are spinning either in clockwise or anti-clockwise direction. One note point, this question is asked in assertion and reason. Each set of principal, magnetic and azimuthal quantum number and spin quantum number values represent one electron only. Okay, remember this point. Now I'm not going in detail to discuss all about the quantum number. We will discuss about the key concept through which you can easily solve the numericals and the important questions. Let's start. See here, my dear student, important formulas you must remember. By using these all important formulas, you can directly answer all important MCQs and even your school examination questions. If in the question it is asked to calculate the angular momentum of electron of any orbit, not orbital. If angular momentum of electron of any orbit is asked, you can use the formula nh upon 2 pi that is derived from the Bohr's atomic model. Okay, mvr is equal to nh upon 2 pi. Angular momentum of electron in any orbit is calculated by nh upon 2 pi. Now these are very important. Number of subshell in a shell. If it is a detailed video, I will explain why I am saying n and n square. Just is a short video so that you can recall all the things. Number of subshell in a shell. If question is asked, calculate the number of subshell present in the third shell. So your answer will be 3. Okay. Number of orbital in a shell. The number of orbital in a shell or orbit is n square. N square. Okay. For example, if I say that the number of orbital in the third shell, your answer will be 9 because the square of 3 is 9. The number of electron in an orbit is 2n square. In lower class 9 and 10th you learned that the number of electron in an orbit is 2n square because I think you learned that Pauli exclusion principle. Each orbital can occupy a maximum of 2 electron. If there are n square orbital and each orbital can occupy 2 electrons, so obviously it will be 2n square. So the number of electron in an orbit is 2n square. Number of orbital in a subshell. Number of orbital in a subshell you can also calculate by 2l plus 1 formula. 2l plus 1. Number of orbital in a subshell where L is the azimuthal quantum number. Number of electron in a subshell. If orbital is 2l plus 1, electron will be double of it. So 2 into 2l plus 1, that is 4l plus 2. Okay. And one thing you must remember, like L, when it is 0, the value of the azimuthal quantum number is 0, it represents S subshell. When the value of L is 1, it represents P subshell. When the value of L is 2, it represents D subshell. When the value of L is 3, it represents the F subshell. Now, important formulas. Orbital angular momentum. Before that, I discussed angular momentum of electron in any orbit, not orbital. Now I am going to discuss about the orbital angular momentum. Orbital angular momentum is given by under root LL plus 1 dot, it is multiplication, h upon 2 pi. H upon 2 pi. Orbital angular momentum. Please write this formula under root LL plus 1 dot h upon 2 pi. Similarly, if it is asked to calculate the spin angular momentum, then it is under root SS plus 1 h upon 2 pi, where S is the spin of the electron. Where S is the spin of the electron. Both formulas are almost similar. Just you have to replace L by S if you want to calculate the spin angular momentum, and if you want to calculate the orbital angular momentum, replace S by L and put the value accordingly. Okay, these questions are very simple and only value put based questions. Now total spin of electron in an atom. Total spin of electron in an atom is given by plus minus half into number of unpaired electron. If we have to calculate the total spin, that is a value of S is given by plus minus half into the number of unpaired electron, because if they are paired their spin get cancelled out. So we are not considering the spin of those electrons that are paired in orbital, because they are opposite. One is moving in a clockwise direction and other is moving in the anti-clockwise direction, so the resultant will be 0. So in order to calculate the spin of electron in an atom, we only consider the electron that are present unpaired. Okay, so the magnetic moment, if you have to calculate the magnetic moment, these question can be asked to calculate the magnetic moment of an orbital where this much electrons are present, 2 or 3 electrons. So what you have to do, you have to apply this formula under root nn plus 2 bm. Bm is the unit of magnetic moment, means Bohr magneton. Okay, Bm means Bohr magneton. Don't be confused with the word n. N is not the principal quantum number here. Magnetic moment is calculated by under root nn plus 2 Bohr magneton, where n is the number of unpaired electron. N is the number of unpaired electron, not all the electron. Okay, so if you have to find out the number of unpaired electron by writing the electronic configuration, and then suppose 3 unpaired electron are present, you have to put 3 here and then calculate the value and put the unit Bohr magneton. Okay, important principles like Aufbau principle, Hund's rule, half filled, full filled, and stability, and all the energies rule you already know. That's why I'm not going to discuss all these in details. And you know that the energy of the orbitals is calculated by with the help of Aufbau principle as energy directly proportional to the n plus L values. And in general, if the sum of n plus L is same for the two orbital, then energy is only directly proportional to the principal quantum number, that is n. Okay, after that we will continue in the next class. We'll discuss about the nodes and non-nodes graphs. These videos are especially for those students who know the basics of the quantum number theoretically. My main focus is to inform you all about the formulas and the important topics and how to solve the numerical. Basic idea you must have. Thank you for watching with this video. We'll meet you in the next video. You can also comment the topic on which you want to listen my videos. Thank you. We'll meet you in the next video. Before that, please don't forget to like, share and subscribe our channel. Meet you in the next video.